Hello viewers, so welcome back to the course on matrix computation and its application. So today we are going to discuss the last topic of this course, that is householder transformation or the reflection. So let's do that one. So today we are going to discuss what is a householder transformation or reflection. So let's see that what we are going to discuss about this one. So let's suppose this is my xy plane, and let I choose some vector is there. So suppose this is my vector, or maybe I will just suppose this is my vector u. Now I choose a plane or this is my plane, and let this plane is given by this. So plane is handled by this vector w, because so this w is perpendicular to this plane. So if I put this w here, this is my plane. So this is my plane, or the mirror we also call it. If I change the direction of this w, suppose I change this direction to here, then the plane will also change. So if I change the value of direction of w, then the plane will be this one. So everything depends on this is my plane. So this is my w. If this is my plane, then this is my w. So depending upon the w, that if I change the w, the plane, this plane will change. Now what I want to do is that I want to take the, so this I call it reflection also, or not the reflection, I should call it mirror. Why it is called mirror? Because what I want, that I want to take the image of this vector such that, so let this is the image of this vector and I call it v, such that the, so now from here I can write that my u, the norm of u should be equal to the norm of v. It means their magnitude should be same, and this is possible if I will choose this as a mirror and I will have the reflection of this u, and that is v. It means that this is perpendicular to each other. Now from here, so this is my condition, that the magnitude of u is same as the magnitude of v. And now I am taking this w, so let w is a unit vector. It means w transpose w is 1. Let I am choosing this one. You are not choosing, then doesn't matter, no problem. But if you choose this one, then our life will be much simpler. So let's see that how it is going to happen. Now if you see, so this is my u and this is my v, that v is this one I have taken. Now let's see the projection. So projection of u on w is, so this is suppose my w, and I want to take the projection of this one. So this is my projection of this u on this w, and this projection I know that we can define this projection. So it is u transpose w over w transpose w. So this is the projection, and even I can write this as, that we have already seen that I can define this as a w transpose and w transpose w u. Now it is a unit vector, so I can write this as W transpose U. So, this is my projection of W on U. So, that is we have already seen. Then when we define the projection over a line. So, this is basically a line. If you see this, this is a line. Now, if you see from here, this is my V, this is my U. Now, you can see that this vector, if I take this vector, it will has the length and we are going in this direction. So, I can write that this is equal to minus W transpose. So, this is with the negative sign and I can write as a U. This is also minus W transpose in this direction. Now, from here, let us see from this that I can write from here that U, I take this triangle, that is a right angle triangle here. So, this is a right angle. Now, I can write that the U minus 2 times W transpose U, this is the, because here it is this value. So, I am taking in the opposite direction. So, this is, if I write this plus this, that is equal to V, and from here I can write my V is equal to, so U I can just take common. So, use a vector. So, I can just take this common. So, I can write this is I minus 2 W transpose U. So, I am applying this transformation on U and I am getting this V. This is my V. So, from here I take that this is my H and I call this H as householder matrix, because this is the matrix. So, it is a householder matrix, or I also call it householder transformation, or I also call it reflection. So, this is a reflection matrix and this H is a matrix. So, now from here I can say that H of U is equal to V. So, this one we are able to see. Now, the thing is that one thing also I can see from here that this vector is V and this, so I can call this vector as U minus V, because if I take the V and if I take the vector in this direction parallel to W, so it can be written as U minus V. Okay, so because in this direction I am taking the vector parallel to W. So, from here also U minus V is a vector parallel to W. Now, we have seen that we have started with that let W be a unit vector. Now, I have taken this one. Now, the thing is that I am taking that U minus V is a vector parallel to W. So, now from here I can choose. So, we can choose W as U minus V divided by its magnitude. So, that W we can take. Here we are taking the vector W as a unit vector. Also, we can write then also if W is not a unit vector, then the householder matrix can be written as I minus 2 times and now I have to take W transpose divided by W transpose W. So then it becomes this one. So either you choose W as a unit vector, or you can take the Householder matrix as this one. So these things we are able to see from here. Now some properties I want to discuss about this matrix H. Now if you see from here, then this is my V, and if you can go back in this direction, so I can take this minus V, and if you see from here, I can choose this as the mirror, and if you see, then this, and maybe I can just, I have taken in this direction, so maybe I can take this V is the, so this minus V is that the image of this U. So this is my U, I am taking the image in this direction now. So I can say that minus V is the image of U when we take this mirror as here. So this is the another mirror, this is perpendicular to this one. So that is also one of the way. Now once I find this H, so let us discuss some properties. Properties of H. So my H I am taking I minus 2 transpose, by considering that this is 1. Now let us see, I want to see what is H transpose. So I can write my I minus 2 W transpose. Now let W is a vector, so suppose I take this vector as W1 up to Wn. So this is my belongs to Rn, and I am taking the column vector. So this will become a identity matrix of n cross n minus 2 times. Now W is n cross 1 and W transpose is 1 cross n. So this is a matrix. So I can say that this matrix will be of n cross n. So that is we can see from here. Then I want H transpose, so I can write this as a I minus 2 W transpose, and this one can be written as I minus 2 transpose, and this becomes I minus 2 times, and this is W transpose transpose W transpose. So I minus 2 W transpose, and that is H. So from here H transpose is H. So that implies that H is a symmetric matrix. So this is a symmetric matrix. Now the second thing is that, so after defining this, second property is, now let us see that what is going to happen in this case. What about HU? So I have applied on this, and I want to take its norm square. So this can be written as I minus 2 W transpose U square, and this one I can write as I minus 2 W transpose square. This is just the product of vectors. So I am taking this the matrix applied on U, and now from here this one can be written as, now let us see what is going to happen here. Now let us do this one. I want to see what is this. Square, that can be written as I minus 2 W transpose I minus 2 W W transpose. This one I can write taking the dot product, and this is equal to I minus 2 W W transpose, this one. So, from here I can write this as a I minus 2 W W transpose minus 2 W W transpose plus 4 times W W transpose and W W transpose. Now, from here I can write this as I minus 4 times W W transpose, and this is just the product of the vectors. So, and this is associative. So, I can write from here, then I can write that this is 4 W. Now, if you see from here, this I choose, then its value is 1, because it is a just the unit vector we have taken. So, now from here I can write that this becomes equal to this value, and now I can cancel out, and this is my I. So, from here you can say that the H of u, the norm, if you see, I can write from here that because this norm is going to be maybe I just take I, and then so this one I can write as this value. So, from here I can write that H of u, the norm, is equal to the norm of u. So, this one we can have. Also, now we have just seen that H transpose H, and that is equal to I. Just now we have seen that this is my H transpose and this is H. So, now H transpose H is equal to I. So, which implies that H is an orthogonal matrix. So, this is my orthogonal matrix. I think now these things, first I just wanted to show this value. So, maybe it is not, let us see this one, that what is going to happen here. So I should write here that, let us see. So, this is basically, if I want to see, then this value is, I just want to maybe calculate this thing, that is it. So, let us see what is going to happen. So, I have taken my H transpose H, and this value we have taken, and we found that this is equal to I. So, let us see that what is we are going to write now. So, we have just write this value, and from here we got this, and now, so from here we got that H is orthogonal matrix, and so if H is orthogonal matrix, then from here we can say that H of u is equal to u. That is the property of the orthogonal matrix, because I can define from here, because H of u square can be written as H u transpose u, H u, so that we can write, and this is equal to u transpose H u, and I can write this as a u transpose, and H transpose H is I. So, it is u transpose, and I can write this as square. So, from here I can write that the H u is equal to u. So, we can write like this one. So, it is, we know that it is invariant under H. So, norm of U and its image under the U is same. So, we are able to check this one, that how we are getting this value. So, after doing this one, now the next thing we want to, from the fifth one, if you see from here, if I take the H and applying on W, so what will happen if I take H of W, and if you see from here, H of W will be just in this direction, because this H I am taking here. So, this is my W, W is in this direction and I am going in this direction by taking the reflection. So, I can write from here, then this is equal to minus W. Also, next property is, if I take the H applying on some vector P, and if I take the vector P's, what will happen if I take a vector, that vector is perpendicular in to W. So, if I take the vector P that is perpendicular to W, it means that it will lie in this mirror or in this plane. So, if I want to see that what is HP, then if from here you will see that it is not going to reflect and you will get the only value of P. So, it is, I can say that if the vector P is perpendicular to W, then this is going to happen. Next thing is that the main thing we want to discuss is that, so it is the sixth one, main thing I want to check. So, let us see what will happen when I apply on HU, because I want to show that it should be equal to V. So, I want to show that my HU is equal to V. So, let us see that how we can show this one. So, this one we want to, let us prove, maybe I can write. This one I want to see. So, choose my W as U minus V, that we have already seen that U minus V is a parallel to W. So, we have taken W is equal to U minus V. Also, I can write my U as half of U plus V plus half of U minus V, that I can write. Now, H of U will be half H of U plus V plus half H of U minus V, and U minus V is W, and we have seen from here that H of W is minus W. So, from here I can write that this is equal to half H of U plus V plus half, and this is minus 1. So, I can write V minus U, this one I can write. Now, also if you see from here, then U plus V, so if you see from here that the U plus V will be this vector. If you see, if I take this, extend this one and it is going meeting here, so this will be U plus V basically. So, if you see from here that the U plus V is this vector is a, so that is my U plus V, and U plus V is going in this direction, and U minus V is going in this direction. So, from here let us see what is going to happen. U transpose u minus v. Let us see, I am taking the dot product of u plus v with the u minus v. So, this is equal to u transpose v transpose, and this is my u minus v. So, I can write here u transpose u, then I can write, or maybe I should write negative sign u transpose v plus v transpose u minus v transpose v. Now, u transpose v or v transpose u both are same. It is just taking the dot product. So, now from here I can write that this is equal to u square minus v square, and I know that this is equal to 0 because the magnitude of u is same as the magnitude of v. So, from here I can say that this vector u plus v is perpendicular to u minus v, and from the property, this property, that any vector which is perpendicular to w, and w is my u minus v. So, which implies that h of u plus v will be u plus v. So, from here now I can, maybe I can give this 1. So, I can write that from 1 we get h of u becomes half h of u plus v is u plus v. So, I can write this as a half u plus v plus half, and this is, if you see, it is v minus u. So, that is v minus u. So, it becomes now half of u minus half of u will cancel out and you will get the v. So, from here we will get h u is equal to v. So, this is the way we have defined this one. So, now let us do its application, that what is the application of this one. So, the first application is that, now suppose I have a vector, any vector I am taking. So, this vector is, suppose I am taking u1, u2, un belongs to Rn, and suppose I want to convert this vector into another vector. So, that is suppose my u. So, I want to convert this in another vector v. Suppose that v vector has only v1 and all other elements are 0. It means I am mapping my u into some vector v which has the same magnitude. So, I can write that v into E1, where E1 is just a unit vector 1 0 0 0 0, and the condition is that the norm of u should be equal to the norm of v. So, this is my v basically. So, that is the condition. So, now suppose I want to convert in this form. So, what are the concepts or the things involved, that and the norm of u should be equal to the norm of v. And now the condition is that how to find, so how to find h, because to find h I need to find w, and we have seen that the w is parallel to u minus v. So, we have to see that whether we are taking this w or this w, because u minus v is the, I have taken this u taking this mirror and I got this v, but I can take this mirror also, and then this may be the another image of this one. So, let us see that how to find h. So, these are the steps are involved in this case, that how to find the value of h. So, these are the procedure. Now, first thing is that how to find W. Now, I will choose my W. So, W is, we will choose U plus minus. So, this is my V I have taken. So, I will, what I will do, I will take vector U, keeping its magnitude here, and then multiply by E1. So, my V is basically now become this one, norm U into 1 0 0 0. So, you can see from here that the norm of V is equal to the norm of U, and here we are writing plus minus, because we have seen either it is U minus V or it can be U plus V if you are taking in this direction. So, then the W will be in the terms of P. Now, I want to find this value. So, what we are going to write here, let us see this. So, I will write one theorem. That given a non-zero vector U that is should be not be equal to E1, the householder matrix H defined by the vector W that is equal to U plus minus norm of U E1. Okay, so, this is I am going to write, and is such that, so given a non-zero vector this, the householder matrix H defined by vector this, and H of U becomes minus plus E1. So, here we are writing plus minus, and here it is coming minus plus, because why it is, because suppose I take W is equal to U plus V, it means in this case my U is minus minus V. So, H of U should be in this case minus V. So, I am taking the V here plus sign. So, I should be taken minus here. If it is W is U minus V, then my H of U should be V, because in this case my V is already negative. So, now these things we can see, and from here we can find that this is the value, and that we can verify also. Now, the main thing is that how to choose sign, that which sign we should take, whether we should take plus or negative. So, this is that we should choose, we should take the sign of, so whatever the sign of U1, U1 is basically, if my U is this one, so U1, U2 up to UN. So, I should take the sign of same as the U1 is there. So, we should take the sign of U1 in vector U. It means that my W is always U plus minus sine, or not the plus minus, I should write now, I should write just plus the sine of u1, whatever the sine is this, u e1. So, that should be my w. Suppose my u is 0, 1, 1. So, in that case the sine of 0 is positive. So, I should take the positive value. Let my u is minus 2, 0, 1. Then in this case I will take the sine of u1 is negative. So, I have to take the negative sign here. So, this is the way we can choose the w. Now, let us solve one example that how we can find out this value. So, let us take one example. Suppose I take my u as 0, 1, 1 and I want to convert this into 1, 0, 0. Means I want to reflect this one on E1 such that the vector norm u and the vector v should be same. So, this is what we are going to do. So, we are considering this one. So, first thing is that I will choose that this should not be equal to E1, that is the first condition. Now, so solution. I want to take this one. So, this is my input basically. All right. This is my u1 and that is my input, and I want the vector v such that the norm of u is equal to norm of v, and my v is basically the u 0, 0. So, that is what I want to do. So, let us see. Now, my u is this one. So, the step 1, my u is 0, 1, 1. Step 2. So, I will take the scaling of u, because just for the numerical stability we will do the scaling of u. So, what you do? We find the m. So, that is the maximum norm of u1, u2, un, where my vector u is whatever the vector is this one. So, we will take the maximum norm of that one and then we scaling u by m and I get my new this one. So, that is my new u. So, in this case, so here my m is maximum of 0, 1, 1. So, that is 1. So, in this case my u is same as u. So, I have just taken this one. So, this is my u is same. So, this is my second one. I need to do the scaling. Third one is I need to find my w. So, w is u plus sine of u1 magnitude of u e1, and now the sine of u1 is 0, which means it is positive value. So, it becomes u plus and the norm of u is root 2 e1, and from here if you see this becomes 0, 1, 1 minus root 2 and this is 1, 0, 0. So, from here I will get this value is minus root 2 and this is 1 1. So, I get this W. Now, after getting this W, the fourth one is my H will be, so it is 3, so it is I 3 to W transpose divided by W transpose W, because here it is not a unit vector. So, we have to find this value. Now, from here you will see you will get 1 0 0 0 1 0 0 0 1 minus, now W transpose W is just I think 4. So, it should be 4. So, it will be 2 by 4, and then W is minus root 2 1 1, and W transpose is minus root 2 1 1. So, this is we are able to find. So, now from here I am able to find my H is 1 0 0 0 1 0 0 0 1 minus, so 1 by 2. So, I get this value. So, I get 1 by 2, and then if you do the multiplication, so minus root 2 it is 2. So, I will get the value here, it is 2 root 2, then I am multiplying by 1 only. So, I will get the same vector. So, minus root 2 1 1 minus root 2 1 1. So, I get this value divided by 1, and if you see from here, then my H becomes, so it is just 1. So, I get value 0 here, it is minus 1 by root 2, I can write it is minus 1 by root 2, because minus sign, and 2 root, this I can write as 1 over root 2. So, I get this value, and from here minus 1 by root 2, 1 by 2, 1 by 2, minus 1 by 2, minus 1 by root 2, and minus 1 by 2. So, this is my H, and you can see from here that H is a symmetric matrix and also the orthogonal matrix. If you see from here taking the dot product, so this will be minus minus plus, so this will be 0, and this vector if you see from here it is plus sign, so it will be 1 by 2 and minus 1 by 4 minus 1 by 4. So, it will be, so H is a my so this is my householder matrix, and now you can check from here that what is H of U. So, if you see this one, I take this vector and my U is 0 1 1, and if you do the multiplication, so I am multiplying this by here, so putting it here, so I will, so you will see from here, then I will get 0 minus 1 minus, so I am getting minus 2 by root 2, and then it is 0, and then it is 0, because just multiplying, and from here I can write this as a minus, I can write this as root 2 0 0. So, you can see from there that this is negative of this one. So, you see from here that V we have taken here, this is my V. So, V was in this case root 2 E. So, we have taken, now if you see just with the another color, this is was my V, and V was here root 2 0 0, and now I have taken this one, it is negative of root 2 0 0. So, this is I can write minus V. So, from here you can say that my H of U is minus V. If you see from here, because in this case if I choose the sign plus, I showed this by the theorem, then my h of u will be this one, just negative of that one. But our otherwise our condition should be same, and the thing is that the norm of u should be equal to the norm of p. So, that is always there, you can check from there. So, this way we can find out the vectors in this case, and so we stop here. So, in the lecture today we have discussed about the transformation, that is the Householder transformation, and in that transformation we shown that the H is orthogonal, H is symmetric and satisfying some properties. So, and you find that this matrix H is very difficult to find for different type of vectors, and if the vector is a having more dimension like 5 cross 1 or maybe 10 cross 1, then finding the Householder matrix is quite cumbersome. So, we have to take the help of some programming language to find out the Householder matrices and its application. So, maybe in the next lecture we will take the help of MATLAB or Octave to deal with this one. So, I hope that you have enjoyed this lecture. Thanks very much.